an idea that what is a phase rule, we have to came across a first term which is phase. In chemistry, we have actually three different phases, or I should say three different states. Which are they? They can be solid, liquid and gases. Now, fourth state of matter also exists, but under particular conditions, not in general conditions. So, which kind of state is it? It is a plasma. Now, in general conditions, at room temperature, we can have three different states. First one is solid, second one is liquid, and third one is gas. Now, in certain chemical systems, it has been observed that the phases are changed from one to another. Like, if we provide temperature to any solid substance, it will convert itself, it will melt and convert itself to liquid. Likewise, if we raise again the temperature, then it will be converted to gas. This is basically a conversion. Okay, so how this kind of conversion actually possible? This is possible due to change in temperature, due to change in pressure, because along with change in such kind of conditions, we can change the state of matter. To study such kind of changes, we have a theory, we have a branch which is basically deals with this all changes. This will be studied in our chapter number 5. So let's begin with it here. Gibbs, a scientist named Willard Gibbs, gave the equation which shows the relation between degree of freedom, components and phases of a particular chemical system. This kind of rule is known as Gibbs phase rule. On the name of scientist Gibbs, the name is given Gibbs phase rule, right? So, why we use it and how it can be actually important for us? So, this is the statement of phase rule, right? How we can write it? So, here capital F is equal to C minus P plus 2. Remember that all the terms are capital, not written in small letters, right? So, this kind of relationship which basically shows the relation between degrees of freedom, number of components and number of phases, right? Such relationship governing all the heterogeneous equilibrium was first discovered in 1874 by an American physicist named Willard Gibbs. On the name of Willard Gibbs, we have given a name Gibbs phase rule. And the statement is known as Gibbs phase rule statement. Okay, here capital F, right, is degrees of freedom. Number of degrees of freedom, I should say. After that, capital C is number of components. Then capital P, number of phases. Right? So Gibbs gave the equation which shows the relation between degrees of freedom, number of components and the phases of the system. Such kind of rule is known as phase rule or Gibbs phase rule, which will be written as capital F is equal to C minus P plus 2. Now let's see that what are the applications of Gibbs phase rule, right? As you all know that we have many applications of latest chemical studies. So along with that, we can state it as like it is possible for us to predict by means or to predict qualitatively by means of a diagram the effect of changing the pressure, changing the temperature and changing the concentration on a heterogeneous system in equilibrium. So I should say that we will study that when we change the concentration, when we change the pressure and when we change the temperature. What is the effect on equilibrium of that particular heterogeneous system? Whether the equilibrium gets disturbed or whether it remains same, that we have to understand, or which kind of change actually occurs when we deal with such kind of changes. That we can study with the use of the phase rule. It is actually widely used in metallurgical operations because metals itself or combinations of metals which we know as, or which we will know it as alloys, they form at a particular temperature, even at a particular pressure and concentration. So we have to understand that if we want to form a particular kind of alloy, so how it is possible for us in order to deal with it, right? So to understand this, we will use the phase rule. Okay? So let's see it here. Now, first term that we will have here is phase. From Gibbs phase rule, that is a mathematical expression that we have seen, capital F is equal to C minus P plus 2. So here capital P is phase. What we understood by the phase, right? So let's understood it here. A phase can be defined as any homogeneous part of a system having all physical and chemical properties similar or same throughout. I am understanding, or I am giving you an understanding that how the phase can be defined. You have to understand that a system which has one particular homogeneous part, which has all the physical and chemical properties similar throughout the system, right? This is known as phase, denoted by capital P. Ordinarily, we have three different states of matter. As I said earlier, first one is solid, second one is liquid, third one is gas. These three are known as phases. Now, in phase, a uniform, or in a phase rule, a uniform part of a system in equilibrium is termed as phase. Okay? Let's take different kinds of examples for it. So, a system containing only and only liquid water is one phase system, right? Only a single component, chemical property remains same, physical property remains same. So it is known as one component system. Now, another one is a system containing liquid water and a water vapor is a two-phase system. Why is it so? Because one is in a liquid form, another one is in a gaseous state. So you have to understand here the physical properties are changed, so the phase also changed, and it becomes two-phase system. Understood it properly, everyone? Now, next one. Here I have shown you that how it is denominated. So capital P is equal to 2 for two-phase system. After that we have a system which contains liquid water, water vapor and solid ice in contact with each other. This is known as three-phase system, where the value of P is equal to 3. Okay? Understood it properly? Why we have taken it as a three-phase system? Because one is in liquid, one is in gas, another one is in solid. So all the three physical properties are different, although the chemical formula remains same, but the physical properties are changed, so that it is known as three-phase system. Okay? Now, a system containing only one phase is known as homogeneous system. Now, if a system contains two or more phases in contact with each other or in equilibrium, then it is known as heterogeneous system. Homogeneous means same throughout. Heterogeneous means different. So if we have two-phase system, then it's a heterogeneous system. If we have one-phase system, then it is homogeneous system. So depending upon all this, we can understood that how the number of phases and even the phase systems can be defined and which are the types of it. Right? Now, here we have taken a look on phase. Next we will see in our next session. Thank you so much, everyone.